Hello, welcome back to my YouTube channel. Today we'll be looking at something exciting. We'll be delving into cryptography. We are still into another world of cryptography. We are still looking at cipher, but today we'll be looking at Atbash Cipher. This is for anyone that's fascinated with puzzles and also has interest for ciphers. Well, before we go on, don't forget to hit the subscribe button and ring the notification bell. We'll be looking at a quick overview of what Atbash Cipher is all about. Atbash Cipher is a substitution cipher. It's more or less like the ones we've treated earlier, a substitution cipher, but in this case, it has a specific key, is not shifting. There's no particular shift. It has a specific key. Wherever we have A, we replace it with Z. Wherever we have B, we replace it with Y. And wherever we have Z, we replace it with A, and so on and so on and so forth. We should, however, note that this substitution cipher, just like every other substitution cipher, it has little or no security. So this is how it is going to look like. For every A, we'll be replacing it with B, and so on. So let's go on. Let's go to the Excel file. So we won't be looking at the English or Latin alphabet alone. We'll also be looking at numbers too. So numbers are meant to be reversed as well. So how are we going to reverse the numbers? We'll be replacing 9 with 0, 8 with 1, and so on and so forth. So for that of the numbers, that's quite straightforward, because for every situation we have now, we want 0. So for that of the alphabet, we can just do, let's say we have 4. Since 9 is also the last, let's say we have 4, 6, 6. So for that of the numbers, you can just have this minus this. So this is what we will be having if we shift it. So it's that simple. And for that of letters, let's create all our numbers. Let's create all our English alphabet. Yeah, there are several ways to achieve that. I will be showing two. Let's start with sequence. We have a sequence of 26. We have 26 alphabet, and we'll be starting with A. And what was the ASCII code of A? That's 65. In case we don't know, we can just do code of A, but we know that as 65 already. 65 is actually that of the uppercase letter, but so that's CHAR. We'll be using CHAR. Sorry for that. Using CHAR. Okay. For that of the lowercase, in case we don't know, and just test it. That's 97. However, for that of A, what's that? For that of A is 65, just as we have it here. So another way of getting it is using base 36 from base in base 36, from 1 to 36, we have the we have the numbers and the alphabet. So if we do a base, if we do sequence of 36, starting from 0, then let me do a base 36. So we will be seeing all that is required. All these numbers are also in text format, as they are aligned to they are all aligned to the left. So in this case, I don't really need the numbers in this case because I already know how to go about that. So I'm only concerned about the alphabet. So I need just 26, and that means I want to start from 10. I want to start from 10. So that's two ways we can achieve that. So, but let me take this off. Let's take one of these as our sample, because for us to work with for us to work with data like this, we have to take a sample, and the sample should have all that we want to work with. Something like A6. A6 does not have number. Okay, let me make use of I think A5 is okay. It has uppercase, it has numbers, it also have a foreign character. And what are we meant to do with foreign character? They are meant to be retained. So let me make use of A5. So let's take care of, let me start with a let function directly, so we don't have to do a lot of, okay, let's call it text, but we have a function named text, so we don't mix it up. So let's text equals to A5. Then let's do a mid of what? Of this text. What was the starting number? Sequence len of this text. I've not closed the sequence. Then we have 1. So this is what we have. So what we want to do is to look up these particular characters in these and reverse them. There are many ways we could have done this. We could have this and have another one, have a lookup, but I don't want to go like it's going to. I'm looking for a way to reduce the steps, so you don't really have to do that, because since our shift, we only have one shift. So let's look this up. Let's make use of smash so as to know the position of each character in this. So okay, let's ignore all these if any's for now. Okay, let's ignore all these for now. Okay, so we have P in the 16th alphabet. So what we are meant to do, just like what we did with numbers, that making use of the last position, which is the largest number, which is 9, to 9 minus the other number. But in this case, we'll be making use of 27. We'll be making use of 27. That's because, okay, we'll be making use of 27. So 27 to reverse these particular ones. Let's see. 27 minus this position. So we are now having 11. Previously, so for this P, it will come. Adding being we have something like Z. When we are using, because we do not have any character, in as 0. We are assuming with this X mash, we are assuming everything is starting from 1 to 26. 1 to 26. So for us to derive Z, character Z, which is the 26th letter, for us to convert that particular one to A, that means it should be, at the beginning we are doing 26 minus 26 minus the last one. Let's assume we are working with dash. That will be 26. That will be 26. Then we'll be doing plus 1 to every, instead of, we'll be doing plus 1. We'll be doing 26. We are still using that, but we'll be doing plus 1. Why we will not be doing plus 1 in that of the number is because the index number is 0. We are starting from 0. But in this case, we can also make use of 26 minus this position, then plus 1. But I could have just said 27 minus that, but plus 1. So in this case now, what's the index position of this in this particular number? So we're having this, you can see we are almost getting there. But in this case, we don't have what? The numbers and the foreign characters ought to be taken care of. But let me take care of the foreign characters. If LA, give me what? Give me this. Give me this. So let me put this in our, we can as well, okay, let me just stick with one because there are always many ways to go about it. Let me, as we are having this, let's deal with our numbers. So for us to deal with our numbers, I can just do 9, convert all these characters into numbers, all this into numbers. So if it is not a number, it's going to give us an error. So we'll be left with just the numbers. There are many ways to go about this. You can just do just as I have usually shown before. The method I used initially is the double unary operator. You can as well use plus 0. You can as well multiply them by 1. So let's stick with the double unary operator. So what I want to do, I want to reverse all these particular. So for 1, will be for 9, will be reversing those numbers, and the way to go about that is to do 9 minus, let me put these ones in a bracket, in a parenthesis. So we've reversed that. So we will now be taking every other thing here. So we'll be making use of if error. If error, if this particular value is here is error, give me this, else give me this. Well, nothing else again, just give me this. That's what we want. So we are done already. The only issue we are having is to make sure this the ones that are in smaller case are in smaller case. So how do we do that? We can consider their code. We can also make use of exact function to know the previous case, the initial character, which is this prince get 100%. We can, so I can just make use of so I want to compare. By this exact is going to give me, I'm doing something like this equals to upper of this. If I want to compare, it won't give me, everything will be true, because this equal sign will not, is not case sensitive. It will not be able to determine if they are having different cases. So what we'll be using here is an exact function. I'm typing different thing. Exact. What is the first character? This. We are making use of that character, the initial character. Then we'll be comparing it with the upper text. So whenever we are having truth, that means the case is, that means since we are comparing this with this, that means for every situation we have true, it is uppercase. We will be retaining the uppercase character, or whatever character we have in the initial else. So I want to, for every situation we have false, I'm going to convert this result I'm having to lowercase. So we already have our Boolean logic already. We just be introducing if function to this case. So if I don't need to do anything again, our logical test is there already. So value if true, we will be returning this same character. Then value if false, then we'll be returning lower character. That's all. Then what are we going to do from there? We just concat it. Can use text function, but you can just concatenate it. From there. That's all. And that's what we are also having there. I think that's right. So you can just, from this situation, we can bring everything together. So what's our step here? Let me just bring everything together. We have alpha, have alpha. Okay. The thing is, this is meant to be, okay, let me just call this M. This is the splitted text now. So it will, let me call that M. So we will not, the next step is to get all alpha characters. Let me call that alphas. All alphabet. No saying mid, no, CHAR, then sequence of what? 26 English alphabet characters starting from A, 65. So that's that. So what we did next was to do a lookup. By do an X mash by getting the exact position X mash. So what are we looking up? What we look up is our M. The M is representing the split text character, the individual character. So where are we searching? The alphas. So no need, so we can ignore all that. So let me see what this is giving. So I think is right at this point. We're having this, and what we did was just multiply 26 minus this plus 1 Let me see what we're having. Okay, but that's the initial. Let me just call this I. I'm bad with naming I'm bad at that. So let me call this I. So what I want to do is to work. Okay, before then we'll be having some if. Let me treat all these if NAs. So if NA give me the M characters back, I think that's fine. So the next thing is to work to convert all these, is to solve for the numbers. So let me just convert all these to numbers. So we are left with the numbers. So what I did was to multiply this, was to minus this from this. So we have 899. So for every situation we are having this value, return this if this I that means when we solve for the alphas. Actually there is an issue with this particular one, because we were meant to have, okay, index of alphas here. I think, is that fine? Okay, this is missing. Let me call these numbers N. let me call this n numbers. It's not really numbers now. Let me just call it n, so I can see what the I will be giving me if I reference it. It's not working fine. Okay, if na, I need think okay, let me try it again. Okay, let me see if na, there should be a comma here. Okay, it's working fine. So for every situation we have value error here. Let me make use of if error. If error, then return I for me. So what is this n giving us? Oh, that's not what I named it. Okay, you see. So the last step was just to let's test for the capitalization, the case. Let's test for that. That's when we make use of exact of m with upper of m. So I don't want to wrap everything here, so let me just make this result this the last step. So let me see what t is giving us. For every situation here, let me take this off. For every situation we're having true, that means the first character is an uppercase, this is a lowercase, and so on and so forth. So that will be the last step. If the logical test is there already, is the one returning truth and false. If t, then what do we want if true? We want what? We want our this n, else the lower of this n. Let me see. So that's good. That's good. Then let me concat it. That's fine. So I can take this off now. So how do we treat for every other characters? How do we treat for every other characters? Let me bring this here. So let me change this. Let me see, that's working fine. So I want it to work for every other place too. So let me introduce map. What's the array? This lambda is text. Let's call it text. Okay, let me call it text. Then comma, then let me take this off, and that's all. Am I missing anything? Bracket close. That's all. Yeah, let me confirm this and this That's all. That's fine. Thank you. Don't forget to hit the subscribe button and ring the notification bell. Thank you for coming. Thank you for watching.